Hello everyone, this is Nelson Shalane. And this lecture we're gonna discuss about the difference between CUDA programming, GPU programming, and CPU programming. First of all, we're gonna talk about the CPU architecture and its advantages, such as the locality, the reduced memory access latency, going along with its temporal locality and the spatial locality. Secondly, we're gonna talk about the efficient use of cache. And third advantage is it has no introspection into how threats are being scheduled, which means that the CPU does not expose that. Whereas the GPU architecture exposes the memory hierarchy and the thread hierarchy, enable the programmers to control thread execution and scheduling, along with its memory hierarchy structure and the thread hierarchy structure. So the thread programming now, we're going to talk about thread programming with C. So we have the P threads with C programming and OpenMP with a C++. Though with the CUDA, we do that by writing one piece of serial code for one thread. GPU makes it parallel by launching the thousands of threads. And the CUDA as well allows programmers to organize threads hierarchically. So the CUDA abstraction of the hardware is that its hierarchy of threads group code and a hierarchy of memory groups data and its hierarchy of a synchronization between threads. For the CUDA development environment, we have a different way of doing that. We have the NVIDIA Inside Integrated IDE. We have a Cuba GDB command layer debugger. We have a visual and command line profiler. We have a CUDA memcheck, sorry, memory analyzer. As well, we have a GPU device management tools. So we're gonna run into a couple of different examples. So this is the GPU invocation code. Here we have a global function which is simply says hello world from GPU, and we have a main function. We have a variable for a character hello world from CPU, and we print it. So here we're gonna call that using a CPU. Then eventually we're gonna call this function by invoking the GPU's um, um, threading, and we're gonna use one unit, and we're gonna call that 10 times. And here we do a reset by calling this line here. So this has been compiled. So let's try it. Okay, there we go. So the first line here is hello world from CPU, which is coming from this string on print. We're calling it from a CPU. And then eventually we're going to see here hello from GPUs 10 times. This is coming from this line in here where we call this function hello from GPU. This notation, we invoke the GPU collations, and this is where we specify how many times we're going to be threading, which is 10 times. Now we're going to talk about the threading. We have a simple example about threading using C. So this is a function where it just sleeps for a second and printing geekwiz from thread. So basically here the main function, we create an ID for a thread, for a single thread. We print here just before thread, and then we create the thread itself by pointing to the thread ID, and as well pointing to that specific function. We have a null here is because there's no arguments. Then here we join it is the way that is going to be called. So we join it. So we join it with this thread ID and with no arguments. And then we print after thread. So we can give it a try for this one. So this one, just to know, this is going to all be being compiled. We're just going to call that binary file. Here it is. So here we have a before thread, and then we have we call the thread here by calling this function my thread font. We were gonna have to print get quiz in here, and then after threading we print this one. So basically we just use a normal way of printing any code before threading. So this one here, the thread join, this true function, the create and thread join, this is what called this function here, but it did that with a multiple threading way. So this is a sample code of introduction to threading. So eventually now we're gonna see a more complex example. Okay, so this code here we have first a struct. We just this is a way of creating an object of a count, a name, and a seconds, and we have this function thread. So this one is just you need to create another structure for a timing for the thread, and then we loop that for a specific count. It sleeps for a couple of seconds according to what we provide, and it prints how much has been awake and not. And here in the main, this is where we just invoke that just a variable seconds. This is the struct thread info, which is this one in here on the top. And here it provides a name for each different. So this is the same structure, but different variables. This is we provide arguments, and like here, this is the count, the name, and how many seconds. Now here we declare three different IDs for each thread. We print before thread. Here we create the thread like just like before, but here specifying for each specific ID. But we calling the same common function here, which is the thread one. With a specific as well here, we provide the timing. So in this loop here, it looped through that this uh, like about six times. It sleeps for the specific timing, and it prints according to the specific iteration by saying awake. So here we do the join. So basically, this is how we call every thread in here. There's three, so we have to call for each one separately. Then we have after thread. So this one again has been already compiled. Now we're gonna call the binary file for that. There we go. And now we have that code here. Man before thread. It's thread one, 0 seconds awake. Thread one, 0 seconds awake, and then it called the main, and then thread one, zero awake. So as we can see here, so thread one is being called all parallelly. All these threads actually have been called in parallel in in different core in the CPU at the same time. This is introduction for GPUs with CUDA and uh, P3 with C. Thank you for watching. That was Nasser Shalem with you. Thank you very much.